Okay, so we'll start with activity 1.11. So here the first question, if A and B are two events of an experiment, then which of the following is equivalent to the law of total probability? Okay, so to better illustrate this, I'll take the help of Venn diagrams. Okay, so here they have given probability of A intersection B. So if I have two events A and B, let's say this is the universal set. Okay, so what does A intersection B represent? So this space represent A intersection B, and also A intersection B complement. So we have rest everything is B complement. So A intersection B complement is this space. So if we are adding this space and this space, we are getting event A. So yes, the first one is right. So what about second one? Okay, so A condition to B multiplied by P of B. So this is just a simplified version of this, right? So what is probability of A condition to B? That is given by probability of A intersection B divided by P of B, right? If I send this to the LHS, I'll have P of A intersection B is equal to P of A given B into P of B. Similarly, both of these are substituted for the respective terms. So and equation B is also right. So what about third one? So here A intersection B is this one, and A complement intersection B complement. A complement intersection B complement is all of this space, right? Okay, so this is not the answer. So what about A complement given B? Okay, so B given B, so A complement given B is this space, right? Multiplied by B. So this can be in turn written as probability of A complement intersection B, and this can be in turn written as probability of A intersection B complement. Okay, so again this is also not equal to A, so you can say this is also a wrong one. So second one, in statistics 1 of IITM online degree course, 40% of the male students and 60% of the female student wrote the final exam. So they have given as probability of male is 0.4 and probability of female is 0.6. If we choose a random student of IIT Madras, so probability that he is a male, that is 40%, probability that the student is female is 0.6. Okay, so the 50% of the male student and the 70% of the female students have passed the exam. Okay, so this can be written as probability of pass given that he is a male is given by 0.5, as well as probability of a student is passed provided that the student is female is given by 0.7. So they have asked us to find out probability of pass. So this is nothing but if we choose a random student from the students of IIT Madras Online, so in the program, so what is the probability that the student is pass? That is the question. So we can use the conditional probability, the probability of pass condition to M into probability of male plus probability of pass condition to female into probability of F. So we can use this formula. Why? Because M and F are complementary, right? So M complement is nothing but F and F complement is nothing but M. So if we substitute here, we'll have 0.5 into 0.4 plus 0.7 into 0.6. So that is nothing but 0.62, option A. So next one. Okay, ICMR has reported some facts regarding COVID-19 on the basis of some sample study. From the study, they have concluded that 5% of our population have the COVID-19 virus and the remaining 90%, 95% do not have the virus. So I'll take probability of virus that this person has, that is 0.05, and the probability that he does not have virus, that is V complement, that is now given by 0.95 with virus. Okay, a RT-PCR test is used to detect the virus, and the test is positive in 95% of the people with the virus. So they have given this. It gives us positive such that as the virus is given by 0.95 again, and the people with the virus is false positive is 1%. So that is probability of positive given that he has no virus, so that is 0.01. so they have asked us to calculate what is the change in percentage that the test is positive. Okay, so to find the change in test is positive, we have to find out what is P of positive, right? So that is given by P of positive given that he has a virus into probability of virus plus probability of positive given that he does not have a virus, or the subject does not have the virus, into probability of not having a virus. So this is given by 0.95, right, multiplied by 0.05 plus, so this is given by 0.01 multiplied by 0.95. so this is given as 0.95 multiplied by 0.05 plus 0.01 multiplied by 0.95. This is given as 0.057. This is the answer. Okay, so next one, an astrologer predicts that if a particular church construction is done till 2024, then there is a 90% chance that XYZ will win the upcoming election. But if the construction won't get completed till 2024, then there is only 30% chance that XYV will win the upcoming election. Okay, so I'll write this as, okay, also they have given as if there is 50% chances the construction will complete by 2024. Okay, so I'll just P of C completion is given by 0.5. okay, so they have also said that the person will win given that there is a completion is 90%, right? So what is the probability he wins given that the completion is not the temple construction is not done? So this is given by 30%, 0.3. okay, so now what are they asking us? Then what is the probability that XYV will win the upcoming election according to the astrologer? Okay, so we just have to write probability of win as probability of win condition to completion into probability of completion plus probability of win subject to condition complement, completion complement into probability of completion complement. So this is nothing but 0.9 multiplied by 0.5 plus 0.3 multiplied by 0.5. so that is nothing but 0.45 plus 0.15, that is equal to 0.6. This is 0.6. Next one, a sample space has 4 outcomes A, B, C and D. The difference of the probabilities of P of A and P of B is 0.4. So they have given us P of A minus P of B is given as 0.4. The probability of event BCD is equal to 0.5. Probability of BCD is equal to 0.5. So what is A complement? A complement is nothing but what? It is B, C and D, right? So this is nothing but probability of A complement. So what is probability of A then? Probability of A is nothing but 1 minus probability of A complement. So that is nothing but 1 minus 0.5, so that is 0.5. Okay, so next they've also given that probability of D is 0.2. so they're asking us what is the probability of A and probability of B. So we already found out what is the probability of A. So the probability of B is equal to 0.5 minus 0.4, so that is nothing but 0.1. So this is the answer. Moving on. First one, if A and B are two events with P of A greater than 0 and P of B greater than 0, which of the following is or are equal to probability of A intersection B? Okay, so you know that probability of A intersection B is given by either this, right? So we can write this as probability of condition A given B is equal to probability of A intersection B divided by probability of B, but we can write probability of B condition to A is given by probability of B intersection A divided by probability of A. So since intersection is commutative, these two are equal. So option 1 as well as option 2 are right. Okay, so remember the second term has to be multiplied here. Okay, in this case the second term is not multiplied, so this is wrong and this is also wrong. Second one, which of the following is or are equal to probability B condition to A? Okay, so this is nothing but probability of B intersection A divided by probability of A. So this can be written as probability of A condition to B into probability of B divided by probability of A. So this option is right. Okay, third one, a student is writing an IAS prelims. In the prelim paper, all the questions are multiple choice questions. For each question there are 4 options. Okay, and only one option is correct. The probability that student knows the answer is 90%. If he does not know the answer, he will select one choice at random. Given that he answers the question correctly, what is the conditional probability that he was guessing? Okay, so we'll write probability that he knows the answer is given by 0.9 and its complement is nothing but K complement is 0.1. Okay, so they have also given that we can also write probability of answering correct given that he knows the answer is always 1, right? And they've asked us to find out what is probability of not knowing the answer given that the answer is correct, right? So this is nothing but guessing. It turns out the answer is right but he does not know, right? So this is what they have asked. Okay, so here So what is the probability that the answer is correct given that he does not know? That is nothing but, there is only one possible answer, right? So it is 1 by 4. Okay, so what is probability that he knows the answer? That is nothing but P of C given A multiplied by probability of K plus probability of C condition to K complement into probability of K complement. So this is nothing but 1 into 9 by 10 plus 1 by 4 plus 1 by 10. So this is equal to 37 divided by 40. So probability of C complement given K complement given C is given by probability of C given K complement into probability of K complement divided by probability of C. So that is nothing but 1 by 4 multiplied by 1 by 10 whole divided by 37 divided by 40. So that is nothing but 1 by 37. This is the answer. Next one, we have 3 companies, Kookaburra, Duke as well as SG, supplies 25%, 35% and 40% of the cricket balls to the international cricket respectively. So I'll just write down the data here. If I choose a random ball, so the probability that it is from Kookaburra K is nothing but 1 by 4. Alright, okay, I'll just write down the percentages as it is. 1 by 25. Okay, probability of Duke is given by 1 by sorry, so this is 25 by 100, so this is 35 by 100, so this is probability of SG is 40 by 100. Okay, so they've also given that past experience shows that 5%, 4% and 2% of the cricket balls produced by these companies respectively are defective. Okay, so this can be written as conditional probability. Probability of a random ball turning to be defective given that it is from K is nothing but 5 by 100, though that can be written as 1 by 20. Okay, probability that a defective ball turns out given that the ball is from Duke is nothing but 4 by 100, so that is 1 by 25. Probability that a ball turns out to be defective given that it is from SG is nothing but 2 by 100, so that is 1 by 50. Alright, so I can apply conditional probability that what is the conditional probability that cricket ball was supplied by Kookaburra if it was turned out to be defective. So I need to find out probability of K given that it is defective. So this is what I need to find. So to find that, first I'll have to find probability of defective. So that is given by probability of D given K into probability of K plus probability of D given du the probability of du plus probability of defective given probability S into probability of S. So that is nothing but 1 by 20 into 1 by 4 plus 1 by 25 into 7 by 20 into plus 1 by 50 into 2 by 5. So this is nothing but 69 divided by 2000. Okay, so we have probability of K given D is nothing but probability of D given K into probability of K divided by probability of D, that is nothing but 5 by 100 into 25 by 100 whole divided by 69 divided by 2000. So that is equal to 25 by 69. This is the answer. So moving on to activity 13, we have first one, that A and B are two independent events, choose the correct statement. Okay, first one is right. What about second one? Second one, this is for disjoint sets, so this is not for independent set, so this is wrong. So we can also write this as P of A given B is nothing but P of A intersection B divided by P of B. P of A intersection B is P of A into P of B whole divided by P of B. P of B is cancelled, so P of A is remaining. This is also right. So this, the inverse, if we change A and B, this is also right. Okay, so second one, which of the following statements are correct? Disjoint non-empty sets are never independent. Disjoint non-empty sets may be independent in some cases. Okay, so what about disjoint set? If a disjoint set, if A and B are disjoint sets, so what about P of A intersection B? This is always 0, right? So this cannot be independent. Why? Because P of A independent B has to be P of A into P of B, right? But we already know that this is 0, but this we have some value, right? So this will not be equal. So this option is wrong, only this option is right. Third one, each set of 3 set badminton between Himanshu and Tapasi is won with equal probability by either player. Okay, so let A be the event that all the 3 sets are won by one player. Let B be the event that at least 2 sets are won by Tapasi, and let C denote that event that at most 2 sets are won by Tapasi. Which of the 2 events are independent? Okay, so let's say I'll denote H if Himanshu wins, if T if Tapasi wins. So I'll write the set A. Set A is given as all 3 sets are won by one player, so that is nothing but H, H, H and T, T and T. Okay, so set B is nothing but at least 2 sets are won by Tapasi, so that is nothing but TTH, THT, HTT or TTT. So what about C? Is this at most 2 sets are won by Tapasi, so that is given by H, H, H. No sets are won by Tapasi. Now at least one set is won by Tapasi. H, H, T, H, T, H, T, H, H and T, T, H, T, H, T as well as H, T, T. Alright, so now we have to check for the independency between 3 sets. I'll find out what is probability of A, probability of B and probability of C. So this is nothing but we have to here the overall sample space we have what we have in totally we have here 8. The cardinality of sample space is 8, so now we have 2 by 8, so that is nothing but 1 by 4. Okay, probability of B is nothing but 4 by 8, that is 1 by 2, and probability of C is 7 by 8. Okay, so what is P of A intersection B? P of A intersection B, in this we have only one common, that is TTT, so we have probability is 1 by 8. Probability of A intersection C, again we have only one common element, so that we have 1 by 8. So probability of B intersection C is nothing but, we have 3 common element, right? So TTH, THT as well as HTT. So we have 3 common terms between these two, that is 3 divided by 8. By looking at this, if we multiply A and B, so we have 1 by 8. So A and B are independent. So what about other two, A and C? If we multiply these two, we'll have 14 by 64, right? So that is not the answer for this. So B and C, A and C are not independent. What about B and C? B and C, if we multiply, we have 7 by 16, but that is also not the answer. B and C is also not independent. Only A and B are independent events.